Okay, so I had to go get you guys from specials, but we're in the middle of just labeling the line plot. So if this is 11 and it's cut into fourths, then this would be 11 and 1/4, which means that this is 11 and 2/4, which means that this is 11 and 3/4, and then this would technically, be the same as 11 and 4/4, because 4/4 is a fraction that's equivalent to 1, and 11 plus the extra gives me 12. Now, all of these, what they expect you to do is just show where those would be represented on the line plot. So sometimes they'll use X's, sometimes they'll use dots, sometimes they'll use little images, but if it's 12, okay, I'm just going to put an X at 12. So I'm taking the 12 from over here, just putting it on the line plot. This is 10 and 1/4. So it's easier if you already have things labeled. That way you can very quickly just put an X at 10 and 1/4. This is 11 and 2/4. So I'm going to stick an X at 11 and 2/4. And even though if it's not labeled, if that's 11 and 1/4 and that's 11 and 3/4, then 11 and 2/4 would have to be in the middle. This is 10 and 3/4. So I'm going to find it and stick an X there. My next one says 11 and 3/4. I'm going to find it and stick an X there. I have 11 and 2/4 again, and even though there's already an X there, you're just going to stack it on top. So this shows that so far there are two boards with that length of wood. This is 10 and 2/4. I'm going to find it and stick an X there. Whole number 11, find it and stick an X there. Whole number 12 again, you just put your X on top. This is 10 and 2/4, so I'm going to put the X on top because I already have one there. I have 11 and 2/4, so I'm going to stick another X on top of 11 and 2/4. I have the whole number 12 again. I have 11 and 1/4, and then I have 11 and 3/4. The only thing I would absolutely say is they're telling you that there are 14 boards, which means there should be 14 numbers. So the only thing I would realistically want you to absolutely double check is if you're asked to make your line plot, if they're asking you for 14 boards, I need you to make sure you have 14 dots or 14 X's, whatever is showing up. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So I have mine. There are some questions here that go with this specific line plot. So the first one just simply says to describe what each X represents on your line plot. But each X was a length of board. So I'm going to put two things here. I'm going to put that the X's represent data, because that's really what they do. For this specific line plot, it had said that Matthew measures the lengths of 14 boards of wood. He measured to the nearest 1/4 inch, and he tracks the data in his table below. So what those X's really represent is each X represents a piece of wood measured in inches. I know it's tight. See if you can fit that in there. He had 14 lengths of 14 boards. So he has 14 boards, there's 14 X's. Every X is a piece of wood, and he's saying that he had measured them in inches. Number 2 says, which length of board does Matthew have the most of? So if there's only one X here, that means one of the boards is 10 and 1/4 inches. Two X's. Two of the boards are 10 and 2/10 inches. One X. One is 10 and 3/4 inches. There's one board that's 11 inches. There's one board that's 11 and 1/4 inches. There are 3 boards at 11 and 2/4 inches. There are 2 boards at 11 and 3/4 inches. And there are 3 boards at 11 and 4/4 or 12 inches. So what length of boards does he have the most of? He has the most X's here and here, which means that those 2 lengths would be what he has the most of. So if this is between 11 and 1/4 and 11 and 3/4, I'm going to say one of the lengths he has the most of would be 11 and 2/4. The other one that he has the most of is simply 12. So 11 and 2/4, I'm going to add inches, and 12 inches. 3 asks me for the total of the 3 longest pieces of wood. I'm going to grab a different color highlighter really quick. What matters is not the 3 highest numbers. Because he has 3 pieces of wood here, these would be his 3 longest pieces. He has 3 pieces of wood that are all 12 inches long, and that's the longest piece of wood he has. So they want the total of the 3 longest pieces. That means I'm going to take 12 and 12 and 12, and I'm going to add them together, but I know that 12 times 3 is 36. Everything was being measured in inches, so I have 36 inches. You should have a second piece. So I'm going to move my piece of paper off. There are 3 things on your second piece of paper where we're going to just practice. Sorry, I dropped my pencil. So it says, Benjamin measures the lengths of 14 pencils to the nearest ½ centimeter. He tracks his data in the table below. Represent Benjamin's data in the line plot, then answer a few questions about the data. When you go to label your line plot, so you're not going to start counting at 14. That's your first whole number. So you start counting at the very first notch after that, and you go to the next whole number. This one's cut into halves. There's 2 pieces. So if this is 14, then this is simply 14 and a half, which means that's 15. Which means this is 15 and a half. That's 16. This is 16 and a half. That's 17. This is 17 and a half. That's 18. Okay? So instead of doing X's, I want to do dots. I want you to see it more than one way. They have 15. I'm going to put a dot at 15. That's one of the pencils. They have 16 and a half. I'm going to put a dot at 16 and a half. That's another pencil. They have 17. I'm going to put a dot at 17. They have 15 and a half. I'm going to put a dot at 15 and a half. I have 15 again. I'm going to put a dot at 15. 16, I'm going to put a dot at 16. 17 and a half, I'm going to put a dot there. 17 and a half again, I'm going to put another dot there. I have the whole number 18. I'm going to put a dot there. I have 17 and a half again, putting a dot there. 15, putting a dot there. 14 and a half, going to put a dot there. 15 and a half, going to put another dot there. 15, going to put a dot there. They said 14 pencils, which means you should have 14 pieces of data represented, which means you should have 14 dots. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. It's asking what each of your X's on the line plot represents. But he's measuring pencils. It's the length of pencils, so it represents data. I'm going to say that each X represents a length of pencil, and they said that he is measuring to the nearest ½ centimeter, so I'm going to write that they are measured in centimeters. Every X would be the length of a pencil measured in centimeters. The second one asks you for the difference of the longest and shortest pencil. Difference is a word for subtraction, which means we're going to subtract some numbers. They want the longest pencil and the shortest pencil. It doesn't matter that there are 4 dots here. That means that there are 4 pencils that are 15 centimeters long. Look at your line plot. What's the biggest number that actually has data there? His longest pencil should be 18 centimeters. His shortest pencil, the smallest number that actually has data there, his smallest pencil or shortest pencil should be 14 and a half. This is why this little trick matters, because if you have 18 and you want to take 14.5 away, you're going to have to put this over 1. You're going to have to do the backward C. You're going to have to get me a common denominator so that you can subtract fractions correctly. But if you can say that this is 17, this is 17.5, and then this would be the same as 17.2, because this also is a fraction that is equal to 1, and 17 plus 1 more is 18. So instead of me writing it as 18, I'm going to write this as 17.2. I'm still going to subtract. But at this point, I don't really even need to do the backward C, okay? I already have common denominators. So I'm going to make this easy, and I'm going to make this work. My common denominator is 2. I'm going to keep the 2. 2 minus 1 is 1. 17 minus 14, well, that gets me 3. Oops, I put 13. It's 3. That's my fault. Now, when it comes to Progress Monitoring 3 on the computer, if you had to type this in, you would not be able to type in 3.5 because they would read it as 31/2, and that's wrong. So if you had to type this in, then technically you could do the backward C for your answer and say that 2 times 3 is 6, and 6 plus 1 is 7. So this would be an answer. The difference between the longest and shortest pencil would be 3.5 centimeters because everything was being measured in centimeters. But if you had to type this answer in, you have to type your fractions as improper fractions. So you quickly do the backward C, get 7/2, still centimeters. Either way, this is an answer. This is also a correct answer. They'd have to take it. We're going to try 2 more real quick. Kelly records the rainfall each day over the course of 5 days in the table below. Represent Kelly's data in the line graph, then answer a few questions about that data. What matters is that these are all whole numbers, and these are not. So what I would like for you to do is I want you to focus on what is in the 10th place. So I'm going to drag a highlighter down the 10th place. When you go to plot these, I need you to simply round to the nearest whole number, and that's what your dot needs to be closer to. So for instance, if I want to round to the nearest whole number, I would circle the whole number, it's 2. I would underline the 10th place, and that 2 would simply leave me alone. So that 2 stays. But it's not at 2. So if I do day 1 and I simply go to the line for 2, that would be marked wrong. But because that 2 is going to keep that 2 a 2, I'm going to go just a little bit over the 2. It's 2 and just a little bit more. If I go to day 2, and I round to the nearest whole number, I'm going to circle the whole number, which is 2. I'm going to underline the 8, and the 8 bumps me up, which means when I do this, if this would round to 3, my dot is going to have to be closer to the line for 3. If I round day 3 to the nearest whole number, I'll circle the 3, that's the whole number. I'll underline the 9, and that 9 would also bump me up, which means that this would round to 4. It's not equal to 4. You can't go to the line for 4, but I'm going to go pretty darn close to 4. Day 4, round it to the nearest whole number. I would underline this 4, and that 4 leaves me alone. So if you know that halfway would be 0.5, that's pretty darn close to 0.5. So when I go for 4, I'm going to go pretty close to the midway point between 4 and 5. And it doesn't have to be perfect. I'm pretty sure mine's probably not right where I say it is, but that's okay. Okay, it's just a line plot. If you round day 5 to the nearest whole number, that 3 would leave this 3 alone. So I'm going to say that I am still over 3 because it's 3 and a little bit more, but I'm going to go just a little bit above the 3. A line plot means that you take that information and you connect the dots so that you can easily see the trends and you can easily see where is it increasing and where is it decreasing. Number 1 asks for the change in rainfall. Highlight this for me. If they want the change in anything, they're really asking you for a difference, which means that you're subtracting. They want the change in rainfall or the difference in inches from day 1 to day 2. Well, if you're going to subtract, the 2's are the same, but 8 is greater than 2. And anytime you're subtracting, I absolutely 155% need you to put the bigger number up top. So instead of doing 2.24 minus 2.83, because I'm not going to be able to do that, that 8 is greater. Put the 8 up top. You cannot spend $4 if you have 3, so you borrow. That 8, 7, that's 13. That's 12, 11, 10, and 9. 7 minus 2 is 5. Hopefully you stacked your decimal points. 2 minus 2 is nothing. They said inches. I'm going to put inches. 2 wants to know what is the change in rainfall. The change in anything, you guys, is simply just the difference. So you're subtracting. They want from day 4 to day 5. If you look at the numbers for day 4 and day 5, day 4 is actually greater because that 4 is greater than 3. So I just need you to put the bigger number up top. So I'm going to do 4 and 49 hundredths. I'm going to take 3 and 30 hundredths away. So 9 minus nothing is 9. 4 minus 3 is 1. Hopefully you stacked your decimal point, so you bring it down. 4 minus 3 is 1. It's being measured in inches, so I'm going to put inches. Done. Last one on here real quick. Emily tracks the money that she earns each day for 6 days. Represent Emily's data in the line graph. Then answer a few questions about the data. All right. This is a little bit different because this one had 1, 2, 3, 4, and 5. This one goes from nothing to 50, nothing, 100. So you would have to think what would be between 50 and 100. But think about quarters. If you have 1 quarter, you have 25 cents. 2 quarters is 50. You have 3 quarters, you have 75 cents. 4 quarters is $1. 5 quarters would be $1.25. It doesn't have to be perfect, but you are going to round to the nearest whole numbers. These are all whole numbers. So whole number is everything in front of the decimal. I'm going to circle all of 120. This 8 would bump me up, which means if I rounded to the nearest whole number, I would round to 121. If this is 125 and I have 121, I'm going to go right underneath that. It doesn't have to be perfect. This is just to recognize, do you understand that this number should come between 100 and 125? And if you do, can you also understand that it is closer to 125 than it is to simply 100? You're going to round to the nearest whole number, everything in front of the decimal point. This one would leave you alone, so that 74 would stay a 74. If this is 75, 74 is less than 75, I'm going right underneath it. You're going to round to the nearest whole number, everything in front of the decimal point, 23. That 3 would leave me alone, and that 23 would stay a 23. So 23 would be less than 25, so I'm going to go underneath it. You are going to round to the nearest whole number. Everything in front of the decimal point, I'm circling all of 56. That 1, would leave you alone, and that 56 would stay a 56. So they're saying, can you recognize that 56 would be between 50 and 75? And that it should be closer to 50 than 75. But it's bigger than 50, so I'm going to go a little bit above it. Day 5, you're going to round to the nearest whole number. I'm going to circle everything in front of the decimal point, and I have 67. That 2 would leave me alone, and that 67 would stay a 67. So 67 would also be between 50 and 75. It's not 75, but it also should be bigger than the 56 that you just plotted. So if I'm going to say that that's 56, I'll go a little bit closer to 75, and I'll put a dot there. Doesn't have to be perfect. The last thing says 95. Going to circle 95. It's in front of the decimal point. That 0 should leave you alone, so 95 stays as 95. 95 should be pretty close to 100, but it's less than 100, so I go underneath. You're going to have to connect the dots in the line plot. So it's easier for you to see the trends, and it's easier for you to see where do you increase and where do you decrease. Number 1 is asking you, how much more money? How much more did Emily earn on her highest earning day compared to her lowest earning day? They're even telling you you're comparing, you're subtracting. Where did she make the most money? The day that she makes the most is day 1. So her highest earning day, that's day 1. Her lowest earning day, where she makes the least amount of money, would be day 3, because she's at $23. They're asking you to compare day 1 and day 3. And if you're comparing, how much more means subtraction. Day 1 is bigger, so I need you to put day 1 up top. I have $120.87. Day 3 is smaller. It's on the bottom. Line up your decimal point so that you can line up your place value. I am taking $23.34 away. If this bothers you, put a 0 there. 8 minus 7 is 3. Sorry, 7 minus 4 is 3. Sorry. 7 minus 4 is 3. 8 minus 3 is 5. Decimals are stacked. They're coming down. You can't spend $3 if you don't have anything, so you borrow. That 2 is a 1. That 0 is 10. 10 minus 3 is 7. Can't spend $2 if you only have $1, so you borrow, and that 1 becomes 11. You're giving them 10 more. 11 minus 2 is 9. They're talking about money, so I'm sticking a $sign on it. 2 says, between which 2 days was there the greatest change in earning? The greatest change would have to be the difference. Now, it might just be easier for you to look. From day 1 to day 2, she's going down. From day 2 to day 3, she's going down. 3 to 4, she's going up. 4 to 5, she's going up a little bit. 5 to 6, she's going up. They want the greatest change. So it might be easier, because you have some space off to the side, for you to check from day 1 to day 2, what does she have? But if day 1 is $120.87 and day 2 is $74.12, you find the difference. Figure out what that would be. Day 2 to day 3, she had $74.12. Day 3, she had $23.34. Figure out the difference. Find out what that would be. Day 3 to day 4, she has $23.34. Oops, sorry, she had 56 on day 4. I'm going to put that up top. She has $56.18, and then $23.34. You just have to keep subtracting until you find it. They want the greatest change, the biggest difference. So I'll try from day 1 to day 2. I would say that 7 minus 2 is 5. 8 minus 1 is 7. Hopefully you stacked them. Can't spend $4 if you don't have anything, so you borrow. That 0 is 10. 10 minus 4 is 6. Can't spend $7 if you only have $1, so you borrow. That 1 becomes 11. 11 minus 7 is 4. So from day 1 to day 2, she has a difference of $46.75. I'm going to see if this gets me a bigger result. It should. Can't spend $4 if you have $2. You borrow. That's 11, 10, 9, and 8. Can't spend $3 if you don't have anything, so you borrow again. That 0 is now 10. 10 minus 3 is 7. 3 minus 3 is nothing. 7 minus 2 is 5. 50 is greater than 46, so day 1 to day 2 is out. This would roughly get me 30 something, okay? 8 minus 4 would be 4. Can't spend $3 if you have $1, so you borrow. That's 11. That's 10, 9, and 8. Hopefully you stacked them. 5 minus 3 is 2. 5 minus 2 is 3. 50 is still greater. Day 3 to day 4 is out. Day 4 to day 5, 56 to 67. It's not going to be greater than 50. I'll try 67 and 95. So I'm going to try day 5 to day 6 just to make sure it's not bigger than 50. Day 6 was greater, so I'm going to put the bigger number up top. Although this is not going to be, but that's okay. I can't spend $9 if I have $6, and I can't borrow from you if you're broke. So we're going to go borrow from the next best person. They're going to give you money to help me, but you still have to give me money. So now that 10 is actually a 9, and now I have money. I'm at 9, so 10, 11, 12, 13, 14, 15, and 16. That would get me 7 fingers. 9 minus 2 is 7. Hopefully they're stacked. Can't spend $7 if you have 4, so you borrow. Now that 4 is 14. That's 7. 8 minus 6 is 2, so no. My biggest difference would be between day 2 and day 3, because that's where I got a difference of 50. So I'm just going to say day 2 and day 3. All right. This would be the end of day 1. So here's what I have for you guys. You have an exit ticket. There's like 7 questions, and really all that it is you looking at data and seeing, can you accurately pull off information? That's it. It's not a grade, but I would like for you to slow down and really look at it so that I know, can we move on and can we move forward, because we really don't have any days to spare at this point, and I want to make sure we're good. There's 6 questions. All right. So you, mine, are going to take both of these papers, the day 1 papers, and I need you to fold them in half for me, because you're going to end up gluing these in. You're going to label these the same way. So I'm going to say that this is data on a line plot. Day 1. This second piece of paper is also being folded. You are also labeling it as data on a line plot, day 1. Do that for me. And then glue them in on the next 2 pages you have. And then you're doing the exit ticket for day 1.